Okay? If you flipped it around though, it would still be deflected to the left because it doesn't care. Now if I put 314 up here, then it would be deflected to the west. And it's not to the west, nor is it to the left.
Double screwed.
Double screwed. Questions? So whenever I use a localizer frequency, I must find the front course number if I want to use that. If I know that front course number with an HSI, I just set that in the head, and then I can just fly. So the only time your student should ever fly the tail of the needle is when? When flying a localizer backwards. When I'm flying a VOR, should I ever fly the tail of the needle? Should I ever track the tail of the needle? Never.
A localizer backwards? What do you mean?
Ooh.
Like you're flying in reverse?
Here you go.
Because we don't have that.
Here we go. This localizer was intended for me to fly a heading of 134. If I decide I'm going to fly 314, I will fly the tail of the needle. This is where people get confused. Oh, I'm on the back course. Well, which direction are you flying on the back course? Because if I'm flying this direction on the back course, guess what? Everything's normal. I'm flying the head of the needle, I turn left and right, it's all great. But if I'm flying this direction, put yourself right here. I'm still going to get the same thing that I was getting down here. I'm still going to get the left deflection. I still have to have the needle pointed behind me in order to get that left deflection, so that it does show the course is off to my east. So front course, back course means where I am in reference to the antenna. Flying the needle, either I'm flying it frontwards, the way it was intended, or I'm flying it backwards. So if you ever come out of like Spanish Fork Canyon or something, coming back into Provo and they're landing 3-1, it's awesome. Just tune in that localizer, you can pick it up and just fly it in backwards. Now here at Provo, it's not intended to be flown backwards, so it's a little bit sketchy because they have not tuned it to actually be accurate on the back course. When an actual back course is published, they do an extra tuning and calibrate it and everything. So it's a little bit funky on the back, but nonetheless it still illustrates the thing. The best thing to do is, if they're doing 3-1, take off on runway 3-1 and just follow it outbound. You're going to be following the tail of the needle. Okay? This hit me, this understanding. Why do I need to know this? I'm taking off out of Reno, and the departure procedure says, depart outbound on the localizer. Am I flying the head or the tail of the needle? Flying the tail. I'm sitting there looking at him like, what? I'm on the front course though. Don't you fly the head on the front course? Well, not if you're flying it backwards. I didn't understand that. Nobody ever explained that to me. So it became very confusing at that moment. Questions? So, once again, pilot error. If you don't put in 134, you don't put in the front course number, you will get, reverse sensing. Is it reverse sensing? No. It's doing exactly what it's supposed to. It's deflecting to the left just like you told it it should. It's functioning just properly. We just have it set in wrong. Questions? More? Okay. So here's my localizer. What's a glide slope? It's just a localizer flipped up on its side. That's all it is. Same technology, same thing. An up deflection, a down deflection. Okay? A localizer is how wide?
35, 10 miles, 10 degrees.
Is a localizer more or less sensitive than a VOR? More sensitive. So would that make sense?
It makes sense for me.
Okay. What he's reading here, and students are actually having a big problem with this, is there's this diagram that shows this. Okay? This is the service volume of the localizer. What that means is we're supposed to, if I'm over here, so my runway's down here. If I'm outside of this area, the needle may actually deflect in the wrong direction. So when I'm out here, it should give me a left deflection. It might actually deflect to the right if I'm outside of this area. So this is like the service volume area. When does my needle actually come alive? Right in here, 3 to 6 degrees. Well, which one is it, 3 or 6? It's kind of vague. A VOR, we all know, is 10 degrees. So why is it 3 to 6? The localizer is set so that at the threshold of the runway, it is 700 feet wide. Depends on the width of the length of the runway. So if I have a short runway, I'm going to have a wider course. If I have a long runway, I'm going to have a narrower course. So it's the length of the runway. So here at Provo, ours is about 4 degrees. You go up to Salt Lake, it's pretty close to 3 because they got those big old long runways. Okay? A glide slope. So this is why the localizer is so sensitive. It's only 3 to 6 degrees. So we have trouble. The glide slope is how wide? How many degrees?
0.7, 1.4. Did I read that right?
0.7. Point, yes.
0.7 up,
0.7.
0.7 down. So
Yeah. So this one is 3 degrees one side, 3 degrees the other side. A glide slope is only 0.7 degrees. How much is 0.7? It's like nothing. So, why is that information critical to me as a pilot?
That means it's super sensitive.
That means that if my glide slope is alive, how far off am I? So why don't we ever chase a glide slope? Because it's only 0.7 degrees. Okay? So you're going to get it. Students will do it. They start chasing that glide slope, and that thing just goes wild, and they're like, what's going on? It's 0.7 degrees. Are you kidding me? So what that does is that really helps you. If you understand that concept, if that concept really sinks in, if that glide slope needle is even alive, it's moving, you're doing good. You are dang close. Okay? Even if you were coming in, we'll do a katana. So here's your circle. So we're dead on localizer, and our glide slope's just barely above us. If I kept that glide slope just pinned right there, barely above it, would I be okay? I would. Because when I get to my decision altitude, how far off would I be? Like 10 feet. Okay, take 0.7 and draw it out. When you get within a mile of the runway, it becomes so sensitive because literally full deflection is like 20 feet or something. It's ridiculous. So understanding that concept now allows me to understand, okay, that's a very, very sensitive instrument. I need to be very stable in order to track it. So if it's not running away, don't chase it. Just like women, right? If they're not running away, don't chase them. Right, Lisa?
Sure.
That's always worked for her. I'm just kidding.
Okay. So that's a localizer. Okay, your next one. What's an NDB?
Obsolete.
Other than obsolete. Okay, we still have some stuff out there that we have. They're called compass locators. Those are the ones that are probably going to be the last to go away. A compass locator is an NDB, a low frequency NDB. It's only good for like 15 miles. It's associated with approaches. But let's understand some terminology. What is a compass locator specifically? Like in all reality, what is it?
Fix.
It's an AM radio tower. That's all it is. If you've got ADF equipment in your airplane, you could tune in 1160 and track directly to KSL's antenna.
That's what I do. Well, I don't track it. I listen to it when I fly.
Yeah, and you can tune it in actually. If you identify it, you can just listen to the radio while you fly, if you've got an ADF. Okay, that's all it is. What it is AM